So this time we are dealing with stability and moments. We'll start with stability. So start with stability. Stability is the likelihood of an object to topple over when a slight push or pull is administered. Then stability is the likelihood of an object to topple over when a slight push or pull is administered. So stability is divided into three. Stability is divided into three. So we have three types of stability. So we have one, which is stable equilibrium. Then we also have number two, which is unstable equilibrium. Then we have a third one, which is neutral equilibrium. So we have three: stable equilibrium, unstable equilibrium, and then neutral equilibrium. So these are the three types of stability of objects. So we have stable equilibrium, unstable equilibrium, and neutral equilibrium. Okay, so let's look at the first type of equilibrium, which is a stable equilibrium. Stable equilibrium. So an object is said to be in a state of stable equilibrium if a slight push or pull does not cause it to topple over. When you administer a slight push to an object, then the object doesn't topple over. Then we are saying the object is in a state of stable equilibrium. Okay, so we are saying an object is said to be in a state of stable equilibrium when a slight push or pull does not cause it to topple over. So now an example we can give here is an example of a table. So if this is a table, for example, a table has 4 legs. So a table has 4 legs. Now if you were to push this table, it will simply just remain in the same position. So a table is an example of an object which doesn't topple over when pushed. So the reasons why this table remains in the same position or doesn't topple over is that one, this table has a wide base. Then two, this table has what we call a low center of gravity. For an object to be in a state of stable equilibrium, it must have, or it should have, a wide base and a low center of gravity. So now from stable equilibrium, we go straight to unstable equilibrium. When an object is in a state of unstable equilibrium, then a slight push or pull causes it to topple over. An example is a ball pen. So a ball pen will be drawn like this. If this is a ball pen and then this is a level ground, if this is the level ground, you would find that if you were to push or to pull, this ball pen, you will find that it will topple over. It will fall on the other side. So if you were to push, it will fall on the other side. So the reason why this ball pen will fall on the other side or will topple over is because one, it has a high center of gravity. It has a high center of gravity. Then two, it doesn't have a wide base. As you can see, the base here, the base is not wide. So the base is not wide. So the base is not wide. The base is not wide. So an example of unstable equilibrium is a ball pen. So as you can see here, if we are to administer a pull or a push, you find that this ball pen will fall on the other side or it will topple over. Then the reason why it will topple over is because one, it has a high center of gravity, meaning from the ground its height is way above the ground. This is what we mean when we say it has a high center of gravity, meaning the point along this ball pen on which or at which its entire weight is concentrated is way above the ground. That's why we say it has a high center of gravity. Then the base is not wide. Our final and third type of equilibrium or type of stability is neutral equilibrium. Now, an object is said to be in a state of neutral equilibrium when, even when pushed or pulled, the object will just remain in a new position. So an object will just remain or move in a new position. So when you push it slightly, it will remain in a new position. When that happens, the center of gravity will remain at the same height. So an object is said to be in a state of neutral equilibrium when a slight push or pull only makes the object to be in a new position. Now an example is a ball. So an example is a ball. So let's say we have a ball here. So if this one is our ball, even when you kick this ball, you find that it will just change position. It won't topple over, it will just change position. Then another example is a funnel. So if we have a funnel like that, the center of gravity won't change, it will remain on the same height. So the reason why this object is not toppling over is because it is in a state of neutral equilibrium. So as we can see, we have three types of equilibriums. We have neutral equilibrium, we have unstable equilibrium, then we also have stable equilibrium. Okay, so now that aside, let's look at the conditions of stable equilibrium. So there are two conditions which guarantee an object to be in a state of stable equilibrium. One is that an object should have a wide base. So an object should have a wide base. This is one condition for stable equilibrium. Then the other condition is that the same object should have a low center of gravity. Low center of gravity. So now let's look at the differences between center of mass and center of gravity. So for center of mass, so the center of mass is the point on an object where its entire mass is considered to act, or it is the point on an object where its entire mass is concentrated. So center of mass is the point on an object where its entire mass is concentrated. So center of mass is the point on an object where its entire mass is concentrated. Then from the center of mass, we go to the center of gravity. So center of gravity is the point on an object where its entire weight is concentrated. So center of gravity is the point on an object where its entire weight is concentrated. So we end here for now. Until next time.